Hello, everyone. Good afternoon. Um, so, today I'm just going to get started in a couple of minutes, but let me do an introduction of the topic. And first of all, let me say to everybody, Happy Diwali, a big festival. I know I'm a workaholic, so I'm also working on Diwali, but Happy Diwali to everybody. So, today in this webinar, I'm going to be talking about how you can detect fraud, how you can investigate fraud, the various ways you go on doing about it, and then we'll come to the machine learning that how you can detect fraud, how you can understand it preemptively, like even before a fraud is going to happen, you're able to flag that look, this is the fraud going to happen. So this is what we are going to be touching on. It's also going to be so a lot of it, in fact, most of it is going to be kind of a workshop where I'll be using our no code automation platform to achieve the results. And then I'll be looking at the explainability part. So the black box models, I'll be looking at understanding which variables are important in detecting fraud, and then we'll be looking at each and every variable, that how are they impacting by increasing or decreasing, by how much am I going to see increase or decrease in fraud. Then at the very end, I'll be also looking at something called the what if analysis, where I'll be playing around with the values and I'll see that, okay, for this transaction, if I make change into something, what will the probability of that transaction being a fraudulent going to be, the new probability. So this is what we are going to be looking at. Going to be interesting session. I had this kind of a session 3 months ago, and we had a huge audience. I think the right now this webinar only allows 100 people. So after 100 people, it will be a cutoff. Like they won't be allowed. So interesting. My name is Harsh. I'm the head of AI at Cliently. Our company provides a no-code automation platform for data scientists, citizen data scientists, usually marketing sales teams, so that they can do machine learning by themselves. And the no-code automation platform includes data cleaning, feature engineering, model building, deployment, checking the data drift, data quality, later on doing the deployment, all those things. So excited to have you all. I'm going to get started in roughly 1 minute. And by the way, there's a question: is certificate provided? I've been to so many webinars. I've never seen any webinar where a certification would be given. This is not the right place to get a certification. I'm just going to be discussing a very hands-on workshop, how to investigate a fraud. So no certificate from my side. I'm sorry. So, okay. Good afternoon, guys. Good afternoon, my time, 1 p.m., bright sunny morning. I'm going to share my screen. If there's any problem in the screen sharing, or if there's any problem with my audio video, do let me know in the chat and comments. Uh, I'll be able to understand that. Okay, so I'm sharing my screen with everyone. Okay, so I have my screen shared with everyone. Hopefully, everybody can see it. So the topic for today's webinar is fraud detection using no-code machine learning. And a little bit about me. So I've been working for last 8 years in a lot of industries. I've worked in a few countries. I like to call myself good with a lot of marketing data science. I'm not a hardcore computer science engineer. I'm good at programming, but not a hardcore. My passion lies in connecting business with the data science. What is Cliently? A quick overview of Cliently. It's a no-code machine learning platform. We are right now working with 150 businesses, and we've helped them create a lot of machine learning models, no-code machine learning, save them these many hours, ROI $40 million so far. As well as you can do a lot of things like forecasting, segmentation, survival analysis, text mining, a lot of things with our platform. Back to the topic, what is fraud detection? So, a set of activities undertaken to prevent money or property from being obtained through false pretense. So, think about it. In day to day life, this is so ongoing. Today, I was trying to make a transaction at a restaurant. I went for the breakfast. I was trying to make a transaction, and then I used Capital One account. So I got a notification immediately on the app. Look, it looks like a very fraudulent transaction because I'm in a different city. So is it you who's doing the transaction? Then I clicked yes. So this is kind of a understanding fraud before it's happening and then showing it to the user. A lot of companies who don't use good fraud detection, the fraud just happens and they're not able to detect it, and then it's a loss on the customer's end. So a lot of companies use it: banking, insurance. These are the key ones. Anytime there's a transaction happening, there's like always. So I was reading it statistically somewhere. Uh, a global average is 0.1% for a fraudulent transaction. Possibility of a fraudulent transaction. The key is that we do the real time monitoring and we implement whatever practices we want to be implementing. So, why is the need? In 2020 alone, there were $56 billion losses just from fraudulent transactions. Companies end up spending millions of dollars for data science consultant to build data science teams just to solve this simple problem. Okay, it's not a simple problem, it's pretty complex. But if you think about it, like the machine learning, computer vision has solved so many things. This problem looks like a very small problem in comparison to that one. Loss of customers. If the fraud is happening on my credit card, I'm just going to withdraw from the bank. Like I'm not going to continue with that bank. As well as erosion of trust in the brand. I don't trust them any longer. So normally, how are the companies going about it? So there are three ways the companies are doing it today. Guys, give me 1 minute. Let me check if everything is all right. Ah, yes, we could have the PPT later on. Sure. So right now there are three ways to go about it. Number one, anomaly detection. So in anomaly detection, what you essentially do is there are two methods to it for the breakpoint analysis and peer group analysis. So in the breakpoint analysis, you've set your own if else statements. You're not doing any machine learning, and what you're saying is, look, anytime I've set out the rules. If the transaction is happening in the origin city where the credit card is bought, if the transaction is not of the nature, let's say $200, I set the if else statements, and whenever that if else statement breaks, then I know that okay, else it is a fraud. So this is the breakpoint analysis, basically detecting any anomaly, anything which is an outlier, doesn't look like a common thing. And then the other is the peer group analysis under the anomaly detection. So what you're doing is you look at the groups for every customer, every row, and the groups are looking similar. Anytime something which doesn't look similar, you say possibility of a fraud. And again, you can simply use the logic in SQL, use any simple logic. So this is a very primitive way of going about investigating fraud. Okay, the second way is the pattern recognition. So you're kind of doing segmentation, k-means, hierarchical, etc. So anytime something which is not falling into a segmentation, you say, okay, look, I'm doing pattern recognition. This one doesn't look like a regular pattern, so this one has a good possibility of fraud. So this is the second way. Now the third way is the machine learning, and you have to take the class imbalance into account. I'll just go into this one. So first of all, why machine learning? Because machine learning, it gets rid of all these if else statements, the manual conditions. Because think about it, right? How much can a human mind capture? Like there may be thousands of ways, thousands of if else statements where a fraud could happen. Now the human mind will only capture a limited amount of things, as well as it's very prone to So I'm making an intuition right now with my experience in the banking. Okay, anytime the person makes a transaction of more than $200 and it's out of the city more than by 200 miles, so I'm making an intuition, and I may be correct, I may be incorrect, but it's not exactly pinpoint. So machine learning gets rid of it. I don't have to worry about any of those things. The machine learning will find out automatically the conditions for me. I don't worry, and it will do the scoring. So basically it's getting rid of the human intuition. But there's a big caveat. Now if you do machine learning, then you understand the class imbalance. But most of the audience today will be non-data scientists. So let me explain that topic. So in machine learning, there is either the classification target, it could be the multi-classification as well, or a regression target. So when it's a classification target, you have something like 0, 1, 2, class A, class B, and then that is a target. So in this case, my fraud is equal to 1 and my non-fraud is equal to 0. So essentially, the fraud is usually 0.1, 0.2% of the times, right? It's not going to be 10% of the times. So for us, look at this orange thing. This is, let's say, fraud. Look at the blue thing. Blue thing is a non-fraud. So the orange thing is so small in comparison to this that I'll have to do some kind of balancing of the classes. I'll have to make them similar so that I get good results. Otherwise, the machine learning is just going to pick the pattern of the non-fraud, which is the blue, and it's just going to predict everybody as non-fraud. It won't do a good work for the orange color, the fraud. So now we have three options. So one option is oversampling, where you would take the smaller class, which is the fraud, and uh, you would increase the number. So let's say you would make it 5 times, 10 times when you get equal to the blue color, which is the non-fraud. Downsampling would be that the blue color or the non-fraud, you make it to the equal number of the fraud. So now it will. So in both the cases, it's going to look 50-50. It's just that in one place you're reducing the number of smaller class. In one place you're reducing the number of the majority class. And there's a third option, which I tend to do it a lot. You directly deal with them in the machine learning model. So what you say is, you bring the data set to machine learning models and you tell them, machine learning models, that look model, whenever you're getting the prediction of the fraud wrong, I want the penalty to be higher on your prediction. But when you get the prediction of the blue wrong, there is no penalty. Like, I'm fine. So this way, you can also directly deal with it in the machine learning models. Okay, now a quick overview of the machine learning process, and then I'll be jumping onto the application and doing it. So you have some historical data set, it is a must. You clean the data, you make sure that the values are consistent, there's no wrong data entry, all that. You clean the data, you prepare it for the modeling, you do the visualization, scalarization, normalization, just so many things, outlier. Then you do the feature engineering. So a lot of variables are not ready to be sent to machine learning until they've been converted into numeric features. So for example, if there's a date column 0102 2021, the machine learning won't understand it. You have to break it down into the day, into the month, into the year. If you want to do a lot more, you can do further subtraction from today, subtraction from the nearest holiday. So just so many possibilities with every variable. So you have to do the feature engineering to get the best answer. Then you take the class imbalance into account, and then you're building the machine learning model. So usually the tree-based models are the best models, and in the end, you're doing the hyperparameter tuning. So hyperparameter tuning is nothing but this is how I like to explain. So let's say there's a radio and the frequency 93.5, you get the best audio at 93.5 FM. But then sometimes you'll have to tweak around. Maybe 93.556 has the best audio. Maybe 93.57 has the best audio. So you have to play with the audio a little bit to understand where you get the best voice. So this is what we mean by the hyper tuning parameter. So you have to play around with the hyper tuning parameter to see Okay, random forest at this property gives me the best accuracy. And you can use a lot of ways: Bayesian optimization, random grid search. We like to use Bayesian optimization. Okay, so now you're done with the modeling. What next? So now you would want to understand the factors that are leading to fraud and then make long term strategy. So if a factor like anytime I'm processing the card through a visa, there's ten times more likely a fraud is going to happen, then I will have to look at the strategy of something's wrong with the visa card. Now, what is wrong? I'll have to investigate with Stripe. I'll have to investigate maybe with my systems, so I can make a long term strategy. Maybe Visa in the long run. By the way, I'm just making up the Visa card that it's going to be problematic. It's never is. But let's say if we find out that the Visa transactions are mostly there's high chance of fraud, then I can incentivize at the checkout that hey, if you make a payment through Mastercard, we give you 1% cash back, we give you 1% off, etc. And then you score and find out the next fraud. So there's this transaction every time happening, right? Every minute in your company, every second, every 1 hour, every 2 hours. So now whenever that next transaction happens, before that transaction, you're able to predict, okay, this is fraud, this is not a fraud. And then also the other thing is you come up with immediate action to save the losses. Okay, so now enough talking. Let's get our hands dirty. That's what I like to say. So this is a data set. Let me show you the data set. This is on Kaggle. It's a very popular data set. Ethereum fraud transaction data set. Give me 1 minute. Okay. Ethereum fraud detection data set. So basically, there's Ethereum transaction happening, and we're trying to determine if it's going to be fraud or not, right? So this is what the data set looks like. There is index, there is flag. By flag one, we mean the transaction is going to be fraud. See, if the transaction is one, it means it is a fraud. So this is historical data set. And then there are tons and tons of variables. I don't even understand many of them. But okay, fair enough. See, the data is so small, I have to wear glasses. Uh, and then, okay, so let's do this. So what I'm going to be now doing is, by the way, I have code for everybody, and I'm going to share it in a while. So I wrote this code, but this is a very quick, generic code. It almost doesn't do much data cleaning, doesn't do much feature engineering. It's just a quick code I wrote just now, an hour ago, and it builds some basic models. So, but what I'm going to be doing is I'm going to be using our platform because I'm not worried about writing code for right now. So, upload file, transaction data, Ethereum 3.2, sorry. Then once the data set is uploaded on this application, all I have to do is just define the target, and then the report will be created. So the whole data cleaning, feature engineering, model building part, comparing the model, explaining all that is automatically done for us. We don't have to write the code for it, and that saves me a lot of time, especially busy executives like me. So what do you like to predict? I like to predict the flag. The ID is the index. Do you want model explanations? Yes, I want to understand the working behind the models. And now I just so in the backend, it's going to do all the data cleaning, feature engineering. It takes care of everything. So I created this report a while ago. I called this Ethereum explainability. Now it has almost 10,000 observations, almost 50 variables exactly, and the weighted FN is pretty good, 0.98. So it took the class imbalance into account. Now, look at this one. So the actual labels is one. Okay. So 96% of the times when the fraud is happening, we are predicting it to be right. But 4% of the times when the fraud is happening, we are getting it wrong. Similarly, when the non fraud is happening, 99% of the times you get it right. 1% of the times our predictions are off. And it's never going to be 100% accurate. It's machine learning after all. If I were like 100% right, I would have been a guru or a consultant selling my services. So now I want to be understanding. I got this code. Okay. So first of all, I want to be looking at this thing. Um, So think about it, right? So this is a data set and there is flag. So we already know if this is fraudulent or not, right? Look, it has 0 and 1. But what about this data set, the transaction scoring data set? It doesn't have the word flag in it. So look, the average minimum, there's no word flag in it. So what that means is that these are the new transactions going to happen, let's say in the future, and I want to be predicting if they're going to be fraud or not. Right now, I have no way to do it. So I'll do something called scoring. Sometimes you call it deployment as well. So what basically scoring is, it is learning everything from the best model. It is saving that code and then applying that code to the new set of transactions. So once I have this, this is what the prediction preview looks like. I'm just going to do a download. Actually, I downloaded this a while ago. So remember, this one didn't have the fraud, if it's going to be a fraud or not. But now I have an answer. Predicted flag. And there's class 1 probability and class 0 probability. So higher the probability of 1, more are the chances of fraud. And we've done a cutoff at 0.5. So if something is like 0.5, we'll just say like, okay, this is going to be a fraud. So I'm done with the scoring for the new transactions. Now I want to dig into the explainability part, that what is causing the transaction, because I want to be creating strategies around it, right? I want to be saving money to my business. So I'm looking at this one. Let me zoom in a bit. Okay. I'm looking at this one, overall importance. The higher the ranking of the variable, the more important it is in differentiating the fraudulent and the non-fraudulent transaction. So this variable is very important. Total ERC 20. Let me see what that is. Just so many variables. Total ERC. Okay, so this is the total number of Ethereum 20 token transfer transactions. Single most important variable. What is the other important variable? Time difference between the first and the last. The first and the last. Let me look at what this variable is first. First and the last minutes. Time difference between the first and the last transaction. Okay, so time difference between the first and the last transaction is pretty good. Is pretty important. But now you'll come and tell me, okay, Harsh, look, what you're explaining is fine. These variables are important. But does increasing the value of that variable, the fraud goes up, or does decreasing the value of that variable, the fraud goes down? Like how is increasing or decreasing the value of that variable correlated with the target? So this is where I like to dig into every variable. So I'm digging into this variable called time difference between the first and the last minutes. Okay, so if you look at this one, especially here, let me zoom in. Okay, so the score, anytime the score is above 0, that means a fraud is happening. Below, that means a fraud is not happening. So when the time difference between the first and the last transaction in minutes is equal to between 0 to between 0 until the 198 100,000 minutes. Okay, so as long as it is that, it's going to be fraudulent. So what it also means to say is that as the time difference between the first and the last minute goes up, the chances of as it increases, the chances of the fraud also goes down. Sorry, the chance of fraud goes down. So the higher the time difference between the first and the last transaction, the lower the chances of the fraud are. And I can look at this one. Look, suddenly at this point, there's like a high fraud, then it starts going down, 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 down. At this point, it becomes negative. At the point of 200,000 minute, it becomes negative. Now remember, if you go back to this one, summary. Okay, what other variables are important? Min val cent. Let's look at this variable, min val cent. Okay. Now remember, it looks like a flat line, so you may say, why is that coming out to be important? But remember, these Ethereum transactions, there's a lot going on in the first few first few of those variables. So look at this one, how it is impacting so much. I'm zooming in, by the way. So let me look at the definition of this min val sent. Okay, minimum value of ether ever sent. Okay, so look at this one. As the minimum value of ether ever sent, there's like a lot of like it just goes down. So the lower it is, the minimum Ethereum, there's like a very low chances of fraudulent transaction happening. But as suddenly it rises, and this is point 0.7, point 0.8, see, as it goes above point 0.7, point 0.8, suddenly the chances of the fraud start going up. See, the chances of fraud have gone so much up. And then the chances of the fraud again go down. See, the fraud is going up, 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 up. Now it's stable, stable. But suddenly when I see the 0.3, I already covered this. I want to be looking at. Okay. So look at this one. After the Ethereum 15, the chances of the fraud suddenly go down. Now there are, like, it's above zero, right? So there are chances of there are chances of fraud. But suddenly at 59, suddenly it goes up, and from 59 to 102, the chances of fraudulent transactions are very high. So this is how we like to understand each and every variable, and we can make a strategy based on it. So if I was the Ethereum founder, I'm not. I would have been very rich. But if I was, I would have set some principles, some conditions. Like, look, guys, whenever the Ethereum transaction is between that 50 to 100K, like, there's a very high chance of fraud happening. So I could have said those things. Okay. Now I want to be looking at every individual explanation. So I want to be looking at every individual transaction. I want to be looking, let's say, at this guy. Okay, this transaction. So this is reversed, by the way. So what it is saying is that this was not a fraud. This transaction was not a fraud. Okay. And we predicted that this transaction will not be a fraud with a confidence of 0.7. So which means the probability of non-fraud is 0.28 something, 0.28. So now the the orange bars are causing the transaction to be fraudulent. Okay, the blue bars are causing the transaction to be non-fraudulent. Now, so look at this one. The unique received from address, the value of this for this transaction, the value of this variable is equal to 10, and that causes the transaction to be fraud. The total 20 TNX, the value is equal to 8, that causes it to be fraud. But then the time difference between the first and the last minute is 516,000 minutes. So this one causes the transaction not to be fraud. So if you look at the blue ones, they outnumber including the intercept. So intercept is a big component in this one, minus 4.7. So if I sum all of these, the blue and this intercept, they outweigh the blue bars. Hence, this transaction is not a fraud. So I can look at every individual transaction and try to understand that why every individual transaction, like what's causing it to commit fraud and what's not causing it to be fraud. So that's what I mean by the local explanations. Okay, now cherry on the cream, cherry on the cake. I'm forgetting how they say it, but let me show you this one. This one is pretty interesting. Okay, so Whatif analysis, right? So let me change it to the class one. Select, or let me change this variable. The average value received. Select. Okay. So what I'm looking at is, let me zoom in. Okay, can't zoom in. Okay, so I'm looking at this. I'm choosing a very random transaction. I've chosen this transaction. Okay, this transaction has a probability of 0.987, pretty high of being a fraud. Okay, I want to understand if I change something, how will that impact the probability? Let's say I want to change the minimum value sent. Okay, the minimum Ethereum sent. I want to change it to 5 now. Let me see how will that change the probability. Let me press enter and see how will the new probability like. Okay, so the probability of fraud has gone up. Now remember I was discussing that min val cent, the higher it goes up, the more the chances of fraud. So that's what essentially it is saying, that for this transaction, I row number 124, it had an original probability of fraud being 0.987, but as soon as I changed the min val cent to 5, the probability went up just by a little. So I can play around, I can change the values. This is what I like to call the what if analysis. So how by changing the values, I can get an idea what the probabilities would look like. So this is something interesting. Well, now let me come back to the presentation, because there are just a couple of minutes left, so I want to share a quick things. Okay, there's something called dependence plots as well, sharp plots. I'm not going into the details, but I'll make the slide available so everybody can have a look. Uh, okay, almost done. So with that, guys, I would like to say thank you. Let me take the questions, comments if you have. Uh, write to me in the chat column. I can take them up. Also, let me, guys, for those of us who want to leave the call, have got some work, let me share this slide with you so that you can give it a read. Change to anyone with the link. Okay, so I'm sharing the link of the slides. And with that, guys, open to questions, comments. If you would like to add me on LinkedIn, my LinkedIn is harshgupta04. You'll find me on LinkedIn, and we have one webinar every week. So next week we are going to be doing this webinar on churn reduction. Again, great webinar. So do sign up for that webinar if you think these webinar adds a lot of values. Whatever you're doing in your organization, like I just want to spread the data science knowledge and make it like a no code, simple code kind of a thing. Okay, I'm sharing my LinkedIn profile here. A LinkedIn profile. Also, I shared my email address. Like after this webinar, if you have any questions, comments, you want to write it to me personally, you can write it to me on LinkedIn, or you would like to discuss anything with me. I'm happy to do that. Just that I don't have any, like, please don't ask me for jobs or internships. That's not my department. That's managed by the HR. So please, just be considerate about that. Okay, so I'm going to start taking the questions. Once again, those of us who joined late, happy Diwali. Could we have the PPT later? Okay, I shared the PPT. Do you have a demo on a data set with the code? So Abhishek, I'm having a hard time understanding your question. So your question is, do you have a demo on a data set with the code? Are you asking me for a code? Because if you're asking for a code, I'll just share with everybody on the email after the webinar. I have emails of everybody who came to this webinar, so I'll be shooting an email with the code. Thanks for sharing. Can you share the LinkedIn profile here? Okay, share my LinkedIn profile here. Guys, I'm also curious, how are you, if you are doing fraud investigation or if you're doing the fraud analysis in your organization, I'm curious, how are you guys doing it right now? Is it anomaly detection? Is it segmentation? Is it machine learning? How are you guys doing it? And if you're doing machine learning, how are you doing the class imbalancing? I'm just curious, like how the other organizations are working. Rahul has a question: is this a course or Rahul? No course. I don't offer any course. It's just something I do every week to share the insights, to spread the data science awareness, to show how a lot of the audience here is non-data scientists, so show them the power of data science, how they can implement it in their organization. No course. I don't do any courses, and like it's a big thing to create a course. So I'm not part of that industry teaching students. I'm too impatient to teach. So not a course, no certifications, guys. uh, Also, I shared the presentation with everybody. So if you want to go through it, I've shared the link of the data set as well. Do let me know what do you guys think about the presentation. Like, happy to have discussions around it. If you think there can be some improvements, happy to have that as well. So Arun, not 80% of the time. It depends project to project, but I would say roughly 60 to 70% of the times you usually spend on preparing data for the machine learning. Now, if you do it very haphazardly, you don't do a good data cleaning, you don't investigate time into data cleaning, not doing good feature engineering, so your model performance is going to suffer in the end. So that's why we highly recommend data cleaning, machine learning, and that's where product like ours come in very handy. Why they come in handy? Because it gets you rid of all that manual process of the data cleaning, feature engineering. So essentially, bringing down your project duration from 4 weeks, 3 weeks to roughly 1 or 2 days. So that's the power of the automated machine learning platforms. For fraud detection, are we using supervised learning technique for classification purpose? Yes, you could use unsupervised learning as well. It just that happens that anytime we have a tabular data set, uh, simple, easy to understand, we can easily read it. We would always prefer supervised learning. Unsupervised learning, we would prefer when there's like tons and tons of data. We're not able to make out patterns from like pattern machine learning will do it, but like if we look with naked eyes, we have a hard time understanding it. So then we would prefer unsupervised learning. But this one is simple, relative straight data. We like to use supervised learning. The remaining data we have heavily biased, so we usually try bootstrap and then fine tune the data, and then we try ensemble. So not exactly getting the question, but what I'm understanding is that the data is biased. By biased, you mean the imbalance problem. So we usually bootstrap and then fine tune the data, and then we try ensemble. Ensembles are always the best, most of the time, the best model. You combine the tree based models, you have something ensemble, and then you have them stacked, blended. You could try one of them. There's another one as well. So, not exactly understanding the question, but that's not the question. I'm asking how we are doing fraud detection now. Okay, okay, my bad. So how you doing? Interesting. So you have the heavily biased data, and then you try the bootstrap, and then fine tune the data, and then try ensemble. Okay, yeah, seems like great technique. How imbalanced your data sets are? Is it 99 to 1%? Is it 99 to 99.9 to 0.1%? Okay, 98. Yeah, that's pretty imbalanced. That's pretty imbalanced. Again, guys, if it's imbalanced, you have to do either the balancing before bringing it to the machine learning, or once you build come to the machine learning, then you have to tell them, look, model, penalize more. Anytime you're doing the wrong prediction on the rare class, which is the fraud in this case, penalize more, give it more penalty. Because when you give more penalty in the models, the model will say, oh, okay, like if I predict this wrong, the fraud, I'm being penalized. So I better not do it, or I better do it carefully. But okay, on the other hand, if I'm penalizing, if I'm not getting any penalty for doing the majority class, which is the non-fraud, I'm fine. So it will focus more. The model will focus more on the fraud. Sometimes you have 99.8, so we try neural nets, then penalize. Okay, Arun, you're an expert. um, and what is the weighted F1 you usually get? Like, what is the precision recall that you get? Sometimes I like to also do this when it's hugely imbalanced, like 0.1% fraud, 99.9% non-fraud. So what I like to do is, and let's say the models are not doing a good work, so I like to do that. I like to play with the threshold. So right now the threshold may be zero point 0.5 by default. If you make the threshold as zero point 0.3, then the more transactions will be flagged as fraudulent. So you can also play with the threshold. You just want to be matching with the original, like you want to be making it comparable. So historically, if you have 0.1% fraud, with the new transactions, it is very likely that you'll have a 0.1% fraud. So you just want to be making it like same proportion. That's the goal. Okay, yeah, that's good. I mean, you're the expert. You know it. You're doing it. So all power to you. But great to see that you're doing fraud investigation. Guys, any more questions? Or else we wrap it up. It's just supposed to be half an hour webinar. Uh, Happy Diwali, Huda. I'm just going to eat desserts after a long time today. Like, uh, whenever I eat any desserts, I eat so much and I gain on weight. So I'm just going to eat desserts after a really long time. I'm very excited. Yeah, sure. Go ahead. And I was checking out this. I was checking out on television in the Hudson River, in New York City. Like there were like big celebrations the earlier night. There were like firecrackers everywhere. Uh, so it's becoming big. Also, one thing. Next week we have a webinar, customer churn reduction. I highly recommend guys that we sign up, because I'm not just going to be talking about how to find the probabilities of churn and how to come up with action plan to reduce churn based on machine learning. But I'm also going to be doing survival analysis, where I'm going to be calculating the mean residual lifetime of customers. So not just the probability, but also when your customers are going to be churning. So if they're going to be churning, so two people may have the zero point 0.9 probability of churn, and that means they're going to be churning. But one may be churning in next 3 months, and the other may be churning in next 2 years. And the strategy that I'll come up with, both of them are so going to be different. 2 year, I'll make slow progress, like slowly try to get him or her into the door. Make sure that they don't break away from the company, like slow action plan. But for the guy who's going to be churning in next 3 months, I'm going to hurry up, because when she leaves, it's done deal. Like can't do anything. Okay, so there's this question: did you ever try to use any ML model to optimize weights in neural networks instead of using fixed weights in neural network? So the question is, did you ever try to use any ML model to optimize the weights in the neural network? I don't do this. I know this is a very popular technique. I'm quite old fashioned, so I don't do this. Like trying to understand from the various models, the parameters, and then use those weights or parameters in the neural network or ANN. I don't do it. I know it's a very popular approach. I'm yet to try it, and hopefully I try it out soon. But usually, so for the tabular data set, right, the neural networks are not winner most of the times. It's usually tree-based model like Light GBM, XGBoost, Cat Boost, Random Forest. So I like to play around with these models a lot rather than neural network. Okay, so if your data set is changing continuously, uh, what we like to call it is data drift. Like you check your performance of the models. So what you're doing is, um, so let's say you build model and there is 5% fraud happening, and then you're doing scoring on the new transactions. So when you do it the first time, first couple of times, the predictions will be like 5% fraud in the new transactions. But over the time, if the data is changing so continuously, the performance will go down in the scoring data set, like 2% fraud, 1% fraud. So your predictions are off. And even when you see them in your CRM, like, okay, we predicted them to be fraud, but it didn't happen. So the predictions are off. So that when you start seeing this, you start changing, you start giving the models new data. No, the models. So it depends. If the nature of the business is changing, right? You're offering one product for last 2 years, and suddenly you change. You offer a new product. You were offering a $20 product, and suddenly you're now offering a $200 product. So in that case, your data set that you'll be picking has to be different. It will have to be relatable to the $200 product. But if it's a gradual change in the business, or some trend has been like going on for a long time, then you just keep feeding more and more data to the system. Like you can set so you can set in your Python, or we have it in the application as well. Like you're continuously feeding the data every 5 days, every 10 days, depending on how frequently your data changes, how frequently your business is making the decisions or changing its product offering, services, etc. Completely depends case to case. There's no one fixed answer. I have worked with the companies where we built a model 2 years ago and it's still in production. We did have to run it the twice time, and it gives great predictions because the business had been in existence for 70 years and the trends haven't changed in the last 2 years. For some businesses, yes, I had to feed in the model every 2 months, every 1 month, because the values continuously keep changing. So that's what it just depends on the nature of business, the data set that you created, the use case. But always like check with the scoring file. If the values are going down or they're not doing the right predictions, then it's time to feed in more data or look at the data set if that needs to be changed. So no one answer for this. Okay, so this is a real-time problem we are facing now. Our data being changes frequently. If we don't update training data and refresh, our model is going vain. How do we handle such problems? Well, simple. If that's the case, then you have the condition that okay, look, I'm going to be fetching the recent data only, and every week I'm going to be building models. So you can automate that script. If you're doing it in Python, we have it in our platform as well. But let's say you're using Python, so you can set a script that look, every 2 weeks, every 4 weeks, fetch the latest 2 months, 3 months, 4 months, 6 months, whatever you deem fit, that data, and then run the model on it, and then forget the old model, run the model, whichever is the best model, use it to score. So that is how you would go about it. You just need to have uh, the scripts if you're using Python. Okay. Thank you so much. Happy Diwali. This other question, that's what we are doing, but that's costing us dollars at S3 instances. Okay. So if you're not too focused on you can use this. There's this instance on spot instances, right? So you can use spot instances on S3. They're far cheaper if you want to go it that route. But 0.01% of the times they're down. So, but even in that case, okay, this has nothing to do with machine learning. I'm giving a great cost savings idea. You're going to thank me for it, and we do this a lot at our company as well. So what you do is, so you take the S3 instances and you take the spot ones, which are super cheap. And what you do is, you power up your application. I'm guessing you have some application internally you've set up. So you power up your application with a couple of spot instances. So if one spot instance is down, the other spot instance is up. and that way you can save a lot of money. The instance is never down. And if the for example, like if you're updating, you just need to run a model once a week, twice a week, and you need to send the stored values to the CRM. And anytime there's a change, you can accept the delay of plus minus 1 day. So you don't even need to have just one spot instance is enough. Get a 32 GB RAM, 64 GB RAM. Right. No, it's not exactly parallel processing. It's like when so there's a spot instance and a B spot instance. When A spot instance is down, you set up a system so that it uses the B spot instance. So you're doing the cost savings as well as when one of the spot instances is down, like you use the other one. So just look up at the pricing of spot instances and ask your DevOps guy, look, we need to power up the application with 2 or 3 spot instances, like good ones. And that way you'll be able to save money. Okay, perfect. Do you think reinforced learning helps? If you have the tabular data set like this, why don't you do this thing, Arun? Why don't you shoot me an email, or why don't you show me a sample of your data set, and I'll be able to comment better. A lot depends on what kind of data set you have. And a lot of people have this knack of just putting up reinforced learning on everything. That's not a good strategy. Reinforced learning works best on when this supervised learning doesn't do its good job, which means tabular data set, the normal looking data sets. But Arun, if you're going to save money from the AWS, like I definitely need a lot of Diwali gifts. But once you start saving it, of course. Also, look at the. I'm forgetting this. There's this new competitor that came up. It got very popular on producthunt.com. Uh, uh, just Google AWS spot instances, alternative product hunt. Like I just saw this one product which does something and makes the spot instances even cheaper. I don't know how they're doing it. So I would really check that one as well. Okay, guys, with that, I would like to say thank you. Anything you want to shoot me afterwards, I'm on LinkedIn. You can shoot me an email on harsh@clientview.com. Uh, there's this last thing. I'm trying to figure out the fine tune between algorithmic changes, model performance, complexity, data integration, capacity, and speed. That's the job of a data scientist. Finding the best optimized mix. Okay, but if you have anything, like shoot me an email or LinkedIn. We can discuss it afterwards as well. Okay. Thank you everyone for coming on the call. Hope to see you next week. Bye.